Hello guys, in this video we will be talking about intercepts of a graph. So intercepts are the points at which graph intersects the x or the y-axis. So x-intercepts are the points where the graph crosses the x-axis, like these points. This one is the point where graph is intersecting with the x-axis. This point and this point, they're all the points where graph is crossing the x-axis. So when we write the intercepts, since the point is on the x-axis, the y-coordinate will be 0. We write the point as an ordered pair as the x-axis, which is 1 here, and its y-coordinate is 0. So when there is an x-intercept, writing the x-intercept as a point, you let y to be 0. Here also 0 is the x part, your y part is 0. Y part is always 0 for the x-intercept. The component is -1. Similarly, y-intercepts are the points where the graph is crossing the y-axis. For example, the graph is passing through the y-axis at 3, so we let x to be 0. So 0 comma 3 is how we write y-intercept as a point. So our intercepts, we may have only one intercept, many intercepts, or no intercepts. For example, here in the first graph, we have only one y-intercept, but there is no x-intercept because the graph is not touching the x-axis. In the second graph, there are 3 points on the x-axis that the graph is crossing, so we have 3 x-intercepts. And on the y-axis, there is only one point that graph is touching, so one y-intercept. In the last point, in the last graph, the graph is neither touching the x-axis nor the y-axis. So we have no x, no y intercepts. And there are also graphs that have infinitely many intercepts, x-intercepts. For example, this graph, you may remember this. This is a sine function. Cosine function also is similar. The function is extending in both directions, goes to infinity. So we have infinitely many x-intercepts. So we have these situations for intercepts. So now I will start solving questions. I will try to solve different types of the questions that are given in the book or that has asked in the website so far. So first example, 2020-2021 second attempt ministry exam question. Find the y-intercept of the given line, y equals -3x minus 4. So how do you find y-intercept? Just let x be 0. So y equals -3 by 0 minus 4. So we have 0 here, 0 minus 4, minus 4. So write this as a point. So my x component is 0, y component is -4. 0, -4, option B is true. Another ministry exam question. This is a different type. The figure is given. It doesn't mention the intercept. It just says find the coordinates of P. So you just need to know what P mean. Here, what does P represent? The P is on the y-axis, so that point represents the y-axis. So we're asked to find y-axis. So if you know what it asks, you can answer the question easily. So to find the y-intercept, we let x be 0. So 2 by 0 minus 4y equals 12. 0 minus 4y, 12. Minus 4y is 12. So dividing both sides by -4, your y becomes -3. So write this as a point. Our x component is 0. Y component is -3. So 0, -3 will be our point. Option D is true. So they are the linear equations. So we have another ministry exam question with linear equations. This is a piecewise function. So find the y-intercept. So it looks complicated at first, but when you know what to do, when you know what the first step is, it is pretty easy. So what is the first step if you are looking for a y-intercept? The first step would be letting x be 0. So remember piecewise functions. If we have a number for x, do we substitute that number into both equations? No, we don't. We have two different equations for two different rules. So we have two different intervals. So we just need to figure out in which interval our number uh, in is our number is. So x will be 0. So where do we have 0? Is 0 less than 3 or greater than 3? 0 is less than 3. So our number will fit in the first case. So let's look at the first region. In the first region, the function is 2x minus 7. So I won't be using the second one. I will be using the first one. So plug in 0 for x in the first one. So 2 by 0 minus 7 is equal to f of x, which is y. So 0 minus 7 is y is minus 7. So you know your x, you know your y. So the point would be 0 comma minus 7, which is option B. All right, let's move on with a quadratic equation. So when you solve a quadratic equation, you should remember zero product property. According to that property, if two factors are multiplied by each other, then one of them is 0. One of the factors is 0. So you write the quadratic equation as two factors multiplied by each other. So this method is called factorization. So we should be doing factorization here. So how do you think we should factorize this? X here 2, 1. One of them will take minus. Since the sign of the middle term is plus, the bigger number will take plus, the smaller one will take minus. So 2 minus 1 is 1, the middle term's coefficient. 2 times negative 1 is negative 2, so that's the correct factorization. So factorize this as y equals x plus 2 times x minus 1. Now let's find the intercepts. What am I looking for? I'm looking for x and y intercepts. So x-intercept, to find x-intercept, we let y be 0. So equalize the given equation to 0. 0 equals x plus 2, x minus 1. Two factors are multiplied by each other, so I will be applying zero product property. So either x plus 2 is 0 or x minus 1 is 0. So if x plus 2 is 0, x is negative 2. If x minus 1 is 0, x is 1. So it turns out to be 3 points. 3 different x values, so 3 different points. Your y is, sorry, 2 different x values, 2 different points. Your x is negative 2 for the first point, y is 0. Similarly, our x is 1 for the second one, and our y is 0. So they are the x-intercepts. What about y-intercept? Y-intercept is easy. Let x be 0. You can use the original equation or the equation that you rewrote it. Y is equal to x squared, 0 squared plus 0 minus 2. So y equals minus 2. Combine these two. Your x is 0. X component is 0. Y component is minus 2. So 0 minus 2 is the y-intercept. Those two are the x-intercept. And this is exercise 11 in the book. Let's move on. Let's solve a ministry question, 2022 first attempt ministry question. The graph of which of the following functions has only two x-intercepts? So the first method it may come in mind is using factorization. First way is factorization. We have quadratic equations in the options, so by using the factorization we can find the x-intercepts and see how many x-intercepts we have. But the question is not asking about the exact value of x-intercept. It doesn't. It just asks about the number. It says which one has two x-intercepts. So factorization is not necessary here. It takes time and it is not easy. So we have another way. So why don't we use the other way? The other way is using discriminant. You may remember discriminant from grade 10 and 11. The discriminant of a quadratic equation is b squared minus 4ac, where a, b, c are the coefficients of a, x squared, and x, and the constant, respectively. We have b squared minus 4ac positive, then we have two different solutions, meaning two different x-intercepts. If discriminant is equal to 0, then we have only one solution, meaning one intercept. And if discriminant is negative, then we have no real solution, meaning no x-intercept. Solution means x-intercept. 2x-intercept. So our case is this. So we are looking for a quadratic equation which has positive discriminant. So instead of factorizing every single option, we will be finding discriminant of every single option. So you use your calculators. So option A, b squared. B is the coefficient of x. So negative 6 squared minus 4 times a is 1, c is 9. This is your discriminant. Find this. Option B, b squared. B is 1 times 4 times c is 1. It will be a negative number, so there will be no solution. Here we have also a negative number. There will be no solution. No, it's 0, sorry. So there will be one solution. Option C, b squared 10 squared minus 4 times a is 1, c is 25. So that's also going to be 0. There will be one solution. Option D, discriminant is b squared negative 7 squared minus 4 times 1 times 10. 49 minus 40 is 9, which is a positive number. So in option D, discriminant is positive, which is our case. If discriminant is positive, we have two roots, two different x-intercepts. So this is the answer. So by just checking the discriminant by the calculator, you can find the answer. But you need to be careful about the sign here. When you type it into your calculator, don't write negative 7 squared as negative 7 squared. So you should write negative 7 in a bracket. Or you also know that negative 7 squared is equal to 7 squared, right? Squaring a negative number turns out to be positive. So you can type 7 squared instead, not to confuse with the signs. Okay, so be careful about using the calculator for this type of questions. So we are done with quadratics. So let's continue with cubic functions. Example 2 in the book, find x and y intercepts of this cubic function. So let's start with the easy one. Finding y-intercept is easy. You let x be 0. So y equals 0 cubed minus 4 by 0, which is 0. X is 0, y is 0, the point is 0, 0. So that's our y-intercept. Let's continue with x-intercept. In this case, y is 0. Y means f of x, so f of x 0 equals x cubed minus 4x. So that requires factorization. You take out the common factor, which is x. So it gives you x by x squared minus 4. So now we use the product property. We have two factors multiplied by each other. Either x is 0 or x squared minus 4 is 0. When x is 0, x is 0. When x squared minus 4 is 0, you can move negative 4 to the other side. X squared is 4. So when you take square root of both sides, x becomes negative and positive 2. So it turns out we have 3 values, so 3 different points. Write the points one by one. When x is 0, y is 0. When x is negative 2, our y is 0. When x is 2, our y is 0. We have 3 x-intercepts, 1 y-intercept, one of which is common.